I'm Tom DelViscio. I am a regional electrification manager at Duke Energy on a team called Transportation Electrification Grid Readiness, which is quite a mouthful. We call ourselves TEGR, or Tiger for short, but we are a dedicated layer at Duke across all of our territories, and I cover North Carolina. And really our primary focus, and we'll get into this, is to be support for two lines of business primarily. It's fleet electrification, and we're really focused on public and private fleets, and then also large public charging projects. So CPOs or charge point operators like Iona or Tesla or Electrify America and the like. So we'll get into that. Quick introduction. All right, so quick agenda here. We're gonna run through this really fast. There's some things I'm gonna kind of tighten up because we've had some market input already. But as we always do at Duke, start with a safety moment. If anyone has been at a site that has electric vehicle chargers, and that could be out in the public or also at work, charger maintenance and charge cord maintenance is really important. We have seen, even at our own sites, dereliction of duty in terms of taking care of chargers, leaving them on the ground. People drive over them, they pull on the cords, there's all kinds of stuff. We've seen chargers fused to vehicles because of inappropriate maintenance. So if you're at a facility or at your home handling these stations, this is dangerous stuff. Electricity will kill you very quickly, so be careful and take care of it. Okay, that done. So the disclaimer is I'm a really busy guy. I present to a lot of different groups. In addition, I have a full-time job doing actual customer work and all kinds of different things. So the presentation sometimes looks a little Frankenstein because I take this part. So if you have seen this presentation in forms before, apologies. But I also find that repeating myself is necessary because we're at that point in the learning curve where I'm constantly talking to folks, sometimes about the same things, but for all the right reasons. I like to say that transportation and the electric utilities have not been bedfellows historically, and so we are being rammed together, and so we need to just repeat the basic ground rules over and over to each other so that we learn to work together, because we have to. It's part of the equation. We cannot leave one part out. It's the vendors, OEMs, it's the charging companies, it's the utilities. We're all partners in this. So two themes based on that, really. Things that are really kind of impacting, and they're really connected. There's a rapid advance in technology that we're seeing. We've done more in the last 2 decades for electric vehicles than I think has been done for over 100 years in combustion vehicles. So we're really hitting on the accelerator. I can't see the gas anymore. Accelerator on this. And this really comes on the residential side, but it's also commercial, and it's also micro-mobility, and it's also air-based and sea-based mobility. We're starting to already have conversations with electric vertical takeoff and landing operations that are looking at airplanes that are fully electric as well. So that's really advancing very quickly, and it's all tied to the power grid. So we really need to be engaged on the early end with this new technology because, frankly, we don't really know how it affects the grid. That sort of blends into the second theme, which is sort of breaking down the silos. And so within the EV ecosystem, I started in this role 2+ years ago and did EVs before that. I've never had as much conversation with other peer utilities than I've had in this period of my career. And it's not because we're competing for vehicles or customers or any of that stuff. It's because this is coming and we're all trying to figure out how best to plan and serve it. And we get a lot of pushback sometimes at conferences. The utilities don't have the power to serve you. They're not ready, all this stuff. We work on a different time scale than technology typically. We're sort of legacy companies. We plan in long-range cycles. So it's really a timing mismatch, but we want to get ahead of it. We want to be more nimble because this is a different marketplace for us. And we're, like I said, we're a necessary and obligatory partner in this. And so this has actually caused a lot of breaking down of silos at the utility as well, because my job by definition is cross-departmental. I can't work on an electric vehicle project without first working with planning and with working with distribution engineering, and then maybe even going up to transmission engineering, and then looking at the regulatory landscape and how we support that. So because of the work that I do, I have to reach out. We're all connected. So, and you'll see that come through. All right, so We talked about this a little bit, and that's kind of the breakdown. I'll go through that real quick. I like to start with this. Others have seen this. So in the beginning, electric vehicles are not a new technology. In the beginning, it was really competition between different types of fuel, essentially. And found this really fascinating, looked into this. These are 3 different types of vehicles. Can anybody hazard a guess at the fuel types that are shown on the screen here? Anybody be brave, come on. Boom, there it is. Okay, so, and at this point in development, they all came out around the same time. Anybody guess age of automobiles? Yep, late 1800s. Okay, so at that point, we had, and that's Edison on the bottom there. So I kind of gave it away. So you've got, that's Carl Benz there in a gas vehicle, and then that's a steam vehicle up there, and then there you've got your electric vehicle with Edison. So they all kind of started at the same place, and I'll go through, let's see if this slide advances. Yes, okay, all right, so there's a study in Nature Energy by a group led by Hannah Nielsen, and they basically took this period of time and they looked at all the details that surrounded it, the industry, the inputs, the context, the conditions, and they put it all in a model. They said, okay, why did gas win? And they kind of ran down the numbers and they put it all together and crunched. And what they found was interesting. In the beginning, and they take the steam was kind of out. It was on the sort of the freight side of things. You can obviously understand like, trains and things like that. But for commercial applications, residential applications, not so good. Parity between gas and electric was about there. So that you could get either or for about the same price. Okay. Similar ranges. Okay, you could do about the same amount of work with both systems. They advanced at about the same rate. So you could go a little bit farther every year with each technology in about the same pace. And electric cars, and I want to draw a little bit of a connection to now, heavier, cleaner, quieter, and were seen as luxury. And primarily were located in the cities because cities had better road infrastructure. And there is also a push to sort of clean up cities in the industrial age. The deciding factor for who won, what they did was they tuned the model forward about 15, 20 years. And they determined in their model that if we had electric utility advancement of 15 to 20 years, the grid had been 15 to 20 years beyond, electric may have likely won the race. So we could have been driving electric vehicles since the 1890s. But that's not what happened. But now we are. So we're sort of back in this curve of adoption and adjustment. Now that's a big picture that's going to not show to you. And it's a lot of vehicles. So this is my EV market update. We've had a lot of this already, so I'm going to kind of burn through this a bit. Got a lot of visuals on adoption types. One of the things I called out, and this was for a room full of engineers last week, is I think a big theme is we're losing at this point compared to other countries, particularly China and Europe. And so you can see the adoption rates here, and big orange is China, blue is Europe, and then we are green. And so if we want to remain at the forefront of development of this type of technology, we're not in a good place at this point. And the current conditions are not going to help. So we're going to fall behind. And there's a lot of implications there, but this is per quarter growth, same trends you can see. This is the growth of available models. So Statistica did a study at 2021. Does anybody want to guess at 22? So they projected around like 425 or something around 2021. Does anyone want to guess right now as of 2025 how many EV vehicles or models are available globally? Anybody hazard a guess? What? Come on, be brave. 125. Well, it was projected to be at 425, so it's up from that. So actually, it's more than the projection. I'll give you that hint. Close. 700 vehicles globally. So there's 700 different models of EVs globally. Anyone want to guess how many in the United States we have currently? Close. 57. Okay, so if there's 700 in the world, we got 57. So again, I say, kind of falling behind. Okay, so I like to do a quick thing. So this is sort of a utility presentation. We'll talk about how we all connect, but I like to do equivalencies. It really helps. Even engineers like it, typically. So when you add load to the grid, there's an impact in terms of utilization, and then the power that's required to support that equipment. So if you added a standard residential charger, you could say it's like adding a dryer, electric dryer to your house. Okay, so we put a few dryers into houses, it's not going to break the grid, especially since those dryers charge overnight, which is when we have low utilization in general. If you start to increase the size of your model, so I've got a F-150 Lightning outside, or if you have a Silverado, you get up to sort of a HVAC system for a 2,500 square foot house. Box truck, talking about sort of lower class vehicles, you're looking at an apartment complex and a plug. You get up to a semi, and now this is way underrated, and I'll show you another one. 150, which is kind of slow these days. You could have a fast food restaurant, the equivalency of one of those in each one of those plugs. And that's 150, and Emily's not serving up 150 anymore. It's 400, and it could be split, but it's 400. Okay, so you start stacking these vehicles on top of each other, and you get to these scales. And the main reason that I like to call this out is, we're working in the light duty space, so you're getting some load add, medium duty gets a little heavier, and you start to quickly get beyond like Transamerica building. A couple of vehicles worth more power draw than the Transamerica building. If you think about the Empire State Building and you think about Class 8 vehicles, how long did it take to build the Empire State Building? How long did the grid have to accommodate that? How long does the grid have to accommodate 25 Class 8 vehicles? You can put that project in less than a year. Empire State Building, I should research this, years of development. Okay, so again, timing mismatch. So what we need to do is figure out how to get ahead of this. And it's going to get worse. And I say worse, but it's an opportunity. So megawatt charging systems are starting to come online. I thought we had more time, but I'm currently working on a few projects with megawatt charging systems in the Carolinas. So we're talking about potentially 3.75 megawatts of energy in one plug. And that's, you can see the equivalencies here, like 1 megawatt, 800 homes, 20 fast chargers, so on and so forth. And so grid operators have to figure out how to bottle this up and serve it while not spreading all that associated cost for a variable load to everyone else. Or how do we manage that? So I'm going to run through real quick. This is from the EV roadmap from EPRI, EVs to scale. So this is something I'm going to run through real quick. It basically, this is looking at megawatt hours of load add as we increase adoption over time. So this is the 2025 sort of baseline, and a megawatt hour of energy. I like that equivalencies. It's the power that it would take to power one American home for about 1.2 months. You could drive an electric vehicle for 3,600 miles. You could power two 60-watt light bulbs nonstop for a year. That's how inefficient those are. You could smelt 137 pounds of aluminum if you wanted to. You could toast about 90,000 slices of bread, or you could run a pool pump for 5 months straight. So, quick run through. Here we go. This is 2025, 2026, 2027, 2028, 2029, 2030. Okay, so you can see it starting to crop up. And primarily, it's going around, this is actually the charger layout. So you can see it's really clustered around urban areas and corridors. And then where you're not there, you don't see a whole lot of growth. And that's something that we like to try to consider too, because not so equitable. If you're building them in South Carolina, but nobody in the area has any charging stations, why would they buy them? Okay, and this is full adoption, which we won't see because this would be very difficult for us to handle. Okay, this is load. So we think about utilization. So my classic analogy is, kWh utilization is like if you pull up to, and you're filling a tank of something, like gas, for instance now, the size of your tank, how much you have to pour into it is the amount of utilization you have. The size of the vehicle is the power you need. So if you pull up in a golf cart, not much power. If you pull up in a semi, completely different situation. So kW is that power that we're looking at here. And this is the same plot, 2025, 2026, 7, 8, 9, And it'll probably come in as full utilization. So you'll see the full utilization or full adoption is black all over the place, which would be a real problem for us. So we need to think about sometimes non-wires alternatives to that. Our team, as I said before, we really kind of serve two different lines of business and are focused on that. It comes in different forms. We do a lot of governmental work. We do a lot of corporate work. There are pioneers that are sort of driving this front edge. So a lot of governments are adopting on a smaller scale. Charlotte, City of Raleigh, City of Durham have made adoptions. Transit agencies are adding electric buses through federal grant programs, but have already implemented things. And then we're seeing corporates that are like Amazon that are bringing in last mile delivery. We also work in that, this is a charge point operator space, so this ecosystem is growing quite quickly. And so IANA is here and we work with them directly. We work with a lot of these folks because we are here to sort of support their operations from a high level portfolio standpoint, so that as they come through our territories, they have a sort of a consistent experience and we can get them on the grid without doing any damage to any of our other customers. Okay, I'm hoping this shows. So this is a specific view of one of the things that we're doing at Duke. It's called our Fleet Electrification Planning Tool. And what we decided was we needed to get ahead of this. So we needed to first find out where our spot loads or our dense areas would be. One good way to do that is to look out over a map and look for distribution centers, because as those trucks come online, they are going to present quite a challenge in terms of load. So that first started in a very manual process where we were kind of just crawling around our maps, but we knew that that wasn't going to be good enough. So what we did was we built internally an AI-informed algorithmic tool to look over our territories, understand and be able to identify clustering of vehicles that could then be categorized, counted, and then allotted into percentages on and projected adoption. So here's kind of what it looks like. Our tool crawls all over our areas and really takes accounting of what's on the map and sort of breaks everything out, puts it into a category, and then allows us a baseline for what's there and how that's working and what we think the adoption rates will be on that technology. And in an effort, and there's a quote from one of our North Carolina utility commissioners, she's actually the head of the commission now, from EPRI 2 years ago, the commissions want us to look to industry for information because they don't want just our opinion on the situation. They want industry's opinion, which we totally understand. So EPRI is a good example, coalescer of information. And so we're actually taking EPRI's data, our data, and overlaying them so that we have really deep insights into how we think the market will progress. Yes, that showed. Okay, so we're trying to do this pragmatically too. We're building tools for planning, but we also have customers right now that we're working with. So this is a good example. We have an electric school bus pilot. It's a V2G pilot. It brought in a number of early adopting partners to say, hey, we'll provide money for procurement of buses, but we're going to use those buses to be able to test whether or not we can pull power from your bus and push it back onto the grid. And the idea here is really when we have constraints in our peak periods, we'd rather be able to take lower cost assets and pull power to support that need, especially since they're so small and they're so specific, versus really upgrading all of the lines or putting in a new sub bay or any of that stuff. That stuff takes a lot of money, a lot of time. So if we can pull from a bus or a depot of buses and support local grid conditions, we might be able to extend the life of our current assets for another 3 to 5 years. And that would represent real savings to us and to the ratepayers. And so this is actually a situation where we have a school bus, a county participating in our program, and we found out that as we put things on, the way that they were charging wasn't actually conducive and fit within our rate structure. And so they got some unintended bills that were a lot higher than they expected. And so we had to dig into this, really take a look at their bills, and then fit it to sort of a heat map of when they were charging, how they were charging, and how we could provide the best information to them to lower costs over time. And we want to take this and then scale this across this market. And so you can do this for all these different EV use cases because they operate in similar fashions. And this is sort of the basis of rate making, but also active programs like managed charging. Okay? So in our opinion, EVs are distributed energy resources, as I just mentioned. So that could be either not charging when it's bad, or charging when there's an opportunity to charge, or dispatching to the grid when we need support. So electrons are very flexible, and we like that. And so we want to be able to leverage that technology across our entire bulk system. Really quickly, we have internal tools that we're building on this front. Hopefully this comes up. Maybe it's going to take a second. So one of our mandates was to provide a public-facing map for solar, so customers could go on and say, where can I place solar on the grid? And have a heat map of that. And so that's where it started, and you'll see it if it eventually pops up. It's a heat map. And so that's a grid hosting capacity map. And we also have a version that's a load hosting capacity maps, or load capacity map. So I can go on in my typical daily functions when I'm working with Emily and her group, for example, and they could say, we want to locate here, here, and here. And I can go into our systems and I can look to see if we have capacity at a high level. I can understand the equipment that's surrounding it so that I can know whether it's fertile ground or we have challenges. And then I can provide information to her group very early on in the process to either save time and energy on selecting that site or another, and then be able to sort of smooth the portfolio across our jurisdictions. But we've had some takeaways. Basically, the idea is there's a couple of common things we need to put into place. These are tools that are useful for both EVs and other technologies, and we're integrating them in a way that we have a lot more real-time and sort of just-in-time information so we can do proper planning and support our customers in the way we need to. The ultimate goal is this. It's really about trying to tune the grid so that we can add all of this growing load and we can support our operations and our customers. And with more and more EV acceptance, we're hoping that balancing that allows us to serve more with current infrastructure, reduce costs, and put downward pressure on rates. And that is the goal. So, and there, like I said, there's a lot of opportunities there that we can get into, but that is the end.